Hello. For Module 2, we're going to talk about functions and recursion. So let's start with functions. A function is a block of code that does certain tasks. Modularizing your program into functions simplifies your program into chunks of codes. Functions can help you avoid repetition of code blocks in your program. So suppose you need a certain line or certain lines of code that you wish to execute several times in your program. So instead of writing those codes many times, you just need to write a single function for that and then you call that function. So how do we define functions in C? The general form of a function call in C is as follows. You have your return type, followed by your function name, your formal parameter lists, and notice that they are enclosed in open close parentheses, and then your function body. So actually, your main function in C is a function. That's why it's called the main function. And if we write our main function, the return type is int, the function name is main. There are actually no parameters used in your main function. That's why it's empty inside the parentheses, and then your function body. So all the things that your program executes is actually part of the function body of your main program or your main function. So let's try this example here. Of course, this is just a program snippet. That's why we need to write a complete program. So we're going to create a function that adds two numbers. So we need our hash include stdio.h, and we write or we define our function. The return type is int. The name of our function is sum. We have two parameters in our function, int a and int b. And then the body of our function. Inside our body, we declare another variable. It's named sum. And then we perform the operation. We store the values or the added values of a and b to sum. So sum is equal to a plus b. And then we return the value, which is sum. And that's our function. Now, that's why we put in our main program a return 0. Because it is expected that your main function returns an integer value. Now, we're done with our function. So how do we call our function? To use a defined function, you must invoke it by calling the function. And the syntax of a function call is as follows. You simply write the function name and then the actual parameter list, where the name is the name of the function and the actual parameter list is the list of parameters to be passed to the function. So if we go back to our code here, there are actually two types of parameters. The first one is the formal parameters, which is these two here. The formal parameters are the parameters found in the function definition. The second type of parameters is the actual parameters, which can be found in the function call. So how do we call the function again? We simply write the function name, which is sum, and then actual parameters. So we have two formal parameters here, which are both integers, and we just need to specify integer values here separated by commas. So let's say 4 and 5. So that is our function call. But let's try if this is correct. So I'm going to compile it. I'll use the, let me clear this first. So GCC minus O sum.c. Okay, it's working, but let's see if we can see anything. So nothing happens because this is just a value and we need something that displays this value. Okay. So let's say I'm going to enclose it in printf or yeah, printf %d. Let's put the \n, then comma, there. So this time I am printing an integer, and that integer is this function called sum. And let's try that. No errors. And there is my sum. Now, every time you call sum, it is an integer. That's why you can also assign it to any integer value or any integer variable. So let's say I'll have int x here, and x is equal to sum for 5. And I'll replace this with x. Okay, let's try that. Same result. Okay, so again, this is our function definition and this is our function call. The variables, the parameters found in your function definition are formal parameters, and parameters found in your function call are actual parameters. So let's go back to the slides to discuss some things. Here, it says, however, since the function returns a value, we must make sure that the returned value is assigned to a variable. In this case, we will put the function call in an assignment statement, and that's what we did here. We put it in an assignment statement. Let's talk about prototypes. And what are prototypes for? So in C, each function should be defined in the lines before a function call, just like in Python. So for example, if I move this function definition here, let's cut that and put it after our main function. Let's see what happens. I received a warning saying that implicit declaration of function sum, which basically tells me that I am using this, or I have this function call here, but anywhere before that, the function was not yet defined or declared. So that's where prototypes come in. So if we use a prototype, it's like we are defining the function even though the body has not, or the function body has not yet been declared. So to declare a function, you need to type the function signature followed by a semicolon. So we just put this prototype before our main program, and we should be able to use our function even if the function is not yet complete, meaning it doesn't have a body yet. So let's try this. So it says here that I just need the function signature, and the function signature is, let's go to our code. I just need to write here int and then sum and then int b followed by a semicolon. So this is my prototype. But the actual function definition is after the main program here. And that's where we can see the body. So let's try this. So I did not get the warning this time. And it still performs the function correctly. There is another way of writing your function signature, and that is by omitting the variable names. So we can actually omit the variable names. So if we go back here, it's like this: int sum int int. So if I go back to my code, I can simply remove A and B. There. And this should also work. So it's still working. But me personally, I like writing the variables. To me, it's much more intuitive to write the variables in the function signature. So let's talk about some details in functions. So tips for using functions. A non-void function can only return at most one value, meaning you should only have one return statement, because the return statement actually stops the execution of the function and or exits the function. So if you have several return statements, the first return statement will be the one that gets executed because it stops the function from performing. The receiving variable of a return value of the function must be of the same type. So if the return type of a function is int, then the variable catching the return value must also be an int. So in our example here, since our function returns an int, therefore x should be an int. Let's say if x is let's try. If we change this to a float, I think this will still work. Let's try. Okay. Some compilers might allow this to work, but here in GCC, you see, we have a warning because we are expecting an integer, but x is a float or a double. So it's very important that the variable catching the function is of the same type. The number and order of actual parameters in the function call must correspond to the formal parameter list of the definition of the called function. Okay. Sometimes here it's our formal parameters here are both integers. That's why we won't really have problems when passing actual parameters here because both parameters share the same type. But for example, it's possible that you have your first formal parameter is a character and then the second one is an integer. Therefore, when you call that function, the first parameter that you're passing should also be character first, and then the second parameter that you should be passing is an integer. So it should always match the order of your formal parameters. All local variables must be declared at the start of the function to avoid errors. So we have the concept of local variables here, which will be discussed in variable scoping. Local variables are variables that can be only accessed inside its own block, meaning its own open close parenthesis. So here in our code here, we have sets of local parameters. Let's say in our main function, we have x as our local parameter, and in our sum function, we have sum as our local parameter. Here, I cannot use x inside this one because x is locally declared in the main function. So let's say if I use x here, let's say I'll replace this with x, and we try to compile. You see, x is undeclared. Even though we can see that x has been declared in our main program or main function, we cannot use it inside sum. So let's replace that with sum. So that is variable scoping. Let's go over the tips first. All functions must be written before the function that uses them. So we've discussed this earlier. However, we can use prototypes so that the function definition can come after the main function. A return statement automatically halts the execution of the function and returns the corresponding value it must return. That's why it's like a corollary to your to the tip that there should be at most one return function, return value, sorry. So the variable scoping, we have discussed local variables. Let's talk about global variables. And global variables are variables that can be accessed by all functions. It is declared outside the scope of any function. So let's go back to our code, and let's say I'm going to declare a global variable. Let's say int y. So you see that int y is outside the main function and it is outside the sum function. Therefore, I can use y here. Let's say y, and then y. And I can also use y here. Let's try that. Y, and then return y. Let's try that if it works. You see, there's no error. And if I compile it, you can see 9 here. Since y is declared outside of both functions, it becomes a global variable and you can use it anywhere in your program. However, global variables can be a cause of confusion in your program. That's why it's not really advisable to use global variables. So that's all about functions for now. In the next coding example, we are trying to convert, or we will try to convert our previous program, the one with computations for geometric areas, into something more modularized. And that is, we're going to use functions for that example. Okay? Bye.